Hello, it's Keith here, and this is lesson 20 of the simple series of my 68,000 assembly programming tutorials. And today we're going to be looking at the NeoGeo again, and we're going to be extending our simulated sprite routine using the fixed layer. Then we're going to allow the sprite to be partially cropped. So before we drew a graphic to the screen using the fixed layer is very simple. It's just a tile map basically. And we drew our Chibico, but now our Chibico can partially go or entirely go off the screen. So this is sort of getting closer to something we could maybe use in a game if we had to have moving graphics. Now obviously the fixed layer has the limitation of being aligned to 8x8 pixel boundaries, so our Chibico is moving in a very chunky fashion today. But next time we're going to look at hardware sprites. But as I always say, using tile maps is simpler if you're just getting started. If you're just trying to get simple things on the screen, make a simple game, I would suggest having a go with the tile map first, the fixed layer in this case, before you worry about hardware sprites. With my YQuest game, I wrote the entire game using the fixed layer and later added hardware sprites, and there was very little needed changing if you design the code correctly. So as I say, definitely worth considering as a simple solution. Now, first of all, we're going to discuss the concept of logical units because this program, has to work in a logical unit fashion. Now, what are the logical units? Well, the logical units are simply a way that I defined the XY coordinates of the objects within the code to allow me to port this simply between 8 and 16 and beyond systems. So 8-bit systems, being 8-bit, don't like values over 256. The problem is, for the cropping to occur, and for systems that have very big screens, I need a coordinate system that allows for values from 0 to 255 for our X and Y coordinates, but parts of those to be off the screen. And so the simple solution I've come up with in all the code I do these days is I use a logical coordinate system where one logical unit is 2 physical pixels. So our 256 by 192, for example, screen would become a 128 by 96 logical unit screen, and we position that visible screen in the center of our logical area. And so this allows, if you look at the example here, if I just get my cursor in the right position, so if we draw our Chibico here, this logical coordinate here, well, only this top right hand corner will be visible on the visible screen. And so that's how it works. As I say, 2 physical pixels to 1 logical unit. That's the calculation. So that's the logical units concept. The next thing we're going to have to discuss, again, because I've discussed it every time, is the concept of how the cropping algorithm I'm using works. And this is the cropping algorithm I have written. Okay, so if you imagine that I have drawn an amazing screen here, this is the screen, and we have a sprite because we need some kind of sprite. There it is. That is a square sprite. If it doesn't look square, you are imagining things and you need to get your eyes checked maybe. And our sprite is moving around the screen. That is a terrible drawing there. Anyway, as it goes off the screen, we will need to do some kind of cropping to our non-square sprite. And so if it goes off the top of the screen, we will need to change the height to this amount, and we will need to skip this part of the sprite before we start drawing. If it goes off the bottom of the screen, we'll need to do things differently. We'll just need to change the height. So change the height to that. If we go over the left hand side of the screen, things are different. Well, we'll need to change the width, of course, to that, and we will also need to skip this part of the first line, and we will need to then skip this part of every successive line because we're drawing across the screen and moving down. Okay, well, what if our sprite is over here? Well, we would start drawing from the first pixel, we would change the width again, and after each line we will skip this part. So that's the sort of theory of what we're doing to draw our sprite to the screen, and you're going to see that in the code. So here is our code. Now this is based on the simple series example. We drew a bitmap on the screen using the tile map before. This has just been extended, the joystick example it was, and now we are doing some cropping. So what I'm not going to discuss is I'm not going to discuss the joystick reading routines or the basic drawing routines or how to get the data into the ROM file, because that's all been covered in previous examples. What we're going to discuss is the new stuff. So we are loading our XY coordinate of our object to D1 and D4, those registers, and we've got this nice new draw player routine here. We are loading the first tile number of our Chibico graphic into D7. We're loading the width and the height in logical units into D3 and D6, and the X and Y are also in logical units. And then we're running our do crop routine, which is going to handle and calculate any cropping that's required. If the sprite is entirely off screen, we need to give up, and that will set the carry so we can give up. Okay, let's take a look at this cropping routine and let's see how it works. Okay, so the cropping routine will start D1 and D4 X and Y position, D3 and D6 are the width and the height, D7 is the bitmap source, the first tile number. Now D2 and D5 are temporary variables throughout this routine, and we also have something known as the sprite H clip, because if we have our sprite, that's our sprite. If our sprite is off the left or off the right, we're going to need to skip some of the tiles after each line before we start drawing the next line. And that's what sprite H clip is going to do for us, but we're going to assume it's going to be 0 because we're going to be optimistic about this. Okay. The first thing we're doing is we're moving our Y position into D0, and then what we're doing is we're subtracting the minimum logical Y position of our screen. So our screen is going to be something like 64 logical units down before the first physical pixel. So that's basically calculating our sprite. And if our sprite is partially off the screen, this is going to convert our Y position to a negative value, and that's going to mean we're going to need to do some cropping, and that's what we're doing here. So if nothing needs cropping, we're skipping the next section, but if it's gone negative, we're flipping that back to a positive number and comparing it to the height of the sprite, because maybe our sprite is massively off the top of the screen and nothing needs drawing at all. In which case we're going to jump to all off screen. What does all off screen do? Well, you remember we said if the carry was set we were going to give up. Well, it's setting the carry and returning so that we give up, nothing to do. So that's what we're doing there. If the sprite is partially on the screen though, we're calculating the number of tiles we need to crop. So because we're working in logical units, we need to skip 4 logical units for the 8 pixels, and we're rounding up here to ensure that we are removing the first part of the tile, because obviously something needs cropping if we're off the top of the screen. We're then storing that new amount to crop from the top in D5, and then we're zeroing the new Y position, because the first drawn pixel is going to be at Y position 0, of course. So that's what we're doing there. We're then rounding the draw position into a number of tiles, and we're storing that in D0. Okay, so that's the top. Now we're going to look at the bottom, and the way we do this is we add the height in logical units to this position, and we then subtract the height of the screen in logical units. And if we need to crop anything, then the carry will be clear, and so what we're doing then is again comparing the amount we need to crop from the bottom to the height of the sprite, and if that's the entire sprite, well, we need to give up again. So then we would skip over there. If not though, we now store this amount to remove from the bottom in D2. So D2 is the amount to remove from the bottom, D5 is the amount to remove from the top. So what we're doing here is we're adding those two together and seeing if anything needs removing from the top and the bottom. If it does, we're subtracting that from the height. We're then going to convert the amount removed from the top into a number of tiles. We're then multiplying that by the number of tiles per line, and we're then adding that to the first tile number, because if the sprite's off the bottom of the screen, we still need to start from tile 1. But if the sprite's off the top of the screen, well, we need to skip Chibico's head in that case, and so we need to skip a few tiles to do that. And that's what we're doing there. We're calculating the number of tiles per line and then removing those tiles from the starting draw position. Okay, so we've done the height, we've done the top and the bottom crop there. We now need to do the left and the right. So we're clearing our 2 temporary variables, and we're going to start the exact same procedure again basically. This time we're taking the X position here, subtracting the minimum X, and we're seeing if that's caused a carry. And if it has caused a carry, then turn around Chibico. Our character must be somewhere like that. So we're off the left hand side of the screen. So again, we're converting that to a number of tiles. So again, we're comparing that to the width of the sprite, seeing if it's entirely off the screen. If not, we're converting it to a number of tiles here, storing that in D5 for later, setting our X position to 0, and we're storing that in our X position drawer there. Okay, so now what we're going to do is the same for the right hand side. So we're adding the width of the sprite, we're subtracting the width of the screen, and if that has left the carry clear, then we need to crop partially off the right hand side. Maybe our sprite is somewhere like this, maybe it's over there, so we need to do some cropping on the right hand side. So that's what we're doing here. We're converting that to a number of tiles and storing that in D2. So D2 is the amount to crop from the right, D5 the amount to crop from the left. So what we're doing is we're adding those two together and seeing if the result is anything to crop. If not, then we're skipping the next section. But if it is, then whether we're cropping the left or the right, then we need to convert the sprite H clip to be the number of tiles to skip after each line. And so we're calculating the number of tiles here by shifting that value to the right by 2 bits. So as I say, if you think about it, we're going to draw our tiles left to right, top to bottom, and whether we're off the left or the right, that means we're going to need to skip some tiles before the next line. So that's what we're going to do here. So we're updating sprite H clip there, and then what we're doing here is we're updating the width. The final thing we need to do is we need to calculate any tiles that we need to skip before we start drawing, because that fireball there may need skipping if we're off the left hand side. And so that's what we're doing here, converting the amount to remove from the left to a number of tiles and adding that to D7, our first tile number. We're now done, so we clear the carry and we return. Okay, so what does our sprite routine actually entail? Well, if I can actually find it in the source code, it's basically the same as it was before. So we have now done our cropping, and we've now got our X and Y position in logical units, and we now want to convert that to tiles, and that's what we're doing here. We're shifting the X and Y position into a number of tiles by shifting to the right twice. Remember, there's 4 logical units per tile because there's 2 pixels per logical unit. So that's converting the X and Y pos. We're then converting the width and the height, and we're giving up if that has resulted in 0 width or 0 height, because we don't want to loop and end up looping infinitely. Okay. So now we need to set our starting tile number. D7 is our tile number, and we're adding 1800. The 1 is the palette number, and the 8 is relative to the position within the fix layer in the ROM file. So that's what we're doing there. And then what we're going to do next is we are going to basically transfer all of the tiles into the VRAM of the fix layer. Now, the VRAM of the fix layer works vertically, but to maintain consistency with every other tutorial I've done in the world ever, we are going to move horizontally. And so this means that the code, I guess, isn't that efficient maybe, but it will work anyway. And so what we're doing here is we're calculating the position of the next line of our tile map horizontally. So we are multiplying the X position by 32 effectively by rotating to the left there. Because, as I say, there are 32 tiles per column. And then we are adding the Y position here effectively. We are skipping the first 2 tiles vertically because the first 2 tiles aren't actually on the visible screen though. Now we are selecting the VRAM destination by writing to 3C quadruple 0, and we're writing our tile number to 3C 0002 there. And after each line has been done, we're updating our VRAM destination, adding 32 tiles to move to the effective horizontal tile, because as I say, if we just added 1, we'd be effectively moving down, which isn't what we want to do. So that's what we're doing there, and we're just repeating till we've drawn the whole line. Once we've drawn 1 horizontal line of our sprite, we are adding the sprite H clip to skip any tiles that need to be removed if our sprite is off the left or off the right of the screen. That's what that is for. And then we're just repeating until we're done, and that's really the end of it. Most of it's basically the same as the previous example with regards to the drawing routine, just with the slight changes for the cropping. And there we go. So that's all we're covering today. If you've liked what you've seen, please like and subscribe. If you like the videos, YouTube recommend them to more people. And if you subscribe, then you will see all of the absolutely amazing content that I've got sarcastically coming in the future. It'll be okay, but it probably won't be amazing. Anyway, hope you've enjoyed what you've seen today. Thanks for watching, and goodbye.